Yeah, that's question number 4. Question number 4. Question number 4 says the dimension represented, the dimension x represents a momentum, P power, C work, D pressure. Let's go to solution. Solution. We'll come to solution. From this dimension, I'll get the unit. From the unit, we'll get the what? The definition. We have m squared t minus 2. This is same thing as, this is the unit of kilogram, which is what? Kilogram. That's dimension of what? Kilogram. This dimension of what? Meter, seconds. And this dimension of seconds. Okay? And this is something as k g m squared divided by x raised to power 2. And this is something as k g times m all over x squared times m squared. That times m, this is over 1. And this time this will give me this back. And this time this will give me this back. And this implies this is the unit of what? Mass. This is mass. And this is what? Acceleration due to gravity. And this is a what? Unit of distance. Meter is the unit of what? Distance. This is meter, the unit of distance. This is meter per second square, the unit of what? Acceleration due to gravity. And this is the unit of mass. Then looking at this, mass times acceleration due to gravity is a force times what? Distance. And the force times distance is the work done. That means work done. That means that this is equals to force times what? Distance. Force times distance is equals to work done. Work done. And when we look at the option there, we see that this is a work done. So our answer is what? C. That's our answer. Let us, that's the question number 5. Question number 5 says the physical quantity that has the same dimension as impulse is dash, which is A, energy, B, momentum, C, surface tension, and D, pressure. Let's go to solution. Solution. We'll look at the solution. The physical quantities that I have. Let us look at what we mean by impulse. You remember that force is equals to mass times what? Acceleration. And this man is same thing as what? Mass. Acceleration is what? Change in velocity over what? Time is the acceleration. And this will give me force is equals to what? Mass into change in velocity over what? Time. And this will give me F equals to what? Mass cross multiplication. I have this. You look at this is over 1. Cross multiplication. I have force T. Force times T equals to what? Mass into V minus what? U, which is change in velocity. And the F T is equals to mass V minus mass U. Then this is what we call impulse. This is called impulse. This is called what? Impulse. And this is called what? Change in velocity. Change in momentum, I mean to say. Change in what? Change in momentum. This is change in momentum. This is what we call change in momentum. Assuming that this vehicle started, or this motion started at initial velocity. If it started from rest, assuming that the motion starts from rest, starting from rest means that U is equals to 0. That means that this man will be equals to what? mv. That starts from rest means U equals to what? 0. The motion, that's the object start from rest. That's the vehicle start from rest. It means that what? This man is equals to 0. This will turn into what? This. And this is what we call what? Momentum. Why this one is called what? Change in momentum. Why this is called what? Momentum. Then the unit of this impulse is the same thing as the unit of momentum. This unit of this impulse is also the same thing as the unit of change in momentum. I think you are getting me right now. I think you get what I'm talking about. The unit of this impulse is the same thing as the unit of what? Change in momentum. The same unit of this impulse is the same thing as the unit of what? Momentum. Then let us look at the unit of impulse. What's the unit of impulse? The unit of impulse is what? Newton per seconds. Come over here. The unit of impulse is what? Newton per what? Seconds. Newton per seconds is the unit of what? Impulse. And the same this Newton per seconds is mean what? Force times what? Time, which is seconds. And what is force? Force is what? Kilogram times what? Kilogram. Force is mass times what? Mass times what? Acceleration due to gravity times what? Seconds. And this is same thing as what? Kilogram meter per second squared. That is acceleration due to gravity times what? Seconds. And this will give me equals to kilogram times what? Meter times what? Seconds, because this is over 1. And this will be over what? Seconds what? Squared. These seconds will kill one of the seconds here. I will have what? Kilogram and what? Meter per what? Seconds. Then this can be given as a dimension. Dimension of kilogram is capital what? M. Dimension of M is what? Capital L. Dimension of seconds is what? T, which can be given as what? M, L, and T minus 1. This is the dimension of what? Impulse. This is the dimension of impulse. I got it from his what? Unit. Look at the unit of what? Impulse. And we'll derive it and get its what? Dimension. You see that I can get the dimension from the unit, and the unit I'll get it from what? Definition. When I see that the unit of impulse is same thing as the unit of what? Change in momentum or momentum. The dimension of impulse is same thing as the dimension of what? Momentum. If you can check it again, you will see that the dimension of impulse is same thing as the dimension of what? Momentum. Come over here, look at momentum. If we can approve, it is momentum V, and this is same thing as what? Kilogram and the meter per what? Seconds. Is it? Is it not? And this will give me what? Taking it, I will have what? Capital M, L, and what? T. And this will give me meter, L, and T minus 1. You see that the unit of momentum is something as unit of what? Impulse. That is question number 6. Question number 6 says, at what respective value of x, y, and z will the unit of force, the Newton, be dimensional equivalent to this? At what will the dimension of force be equivalent to this man? That means they ask us to find the dimension of force, and when we get the dimension of force, we should equate it to this. Let's go to solution and look at the option they give us here. Option A minus 1, 1, 2, 1, 1, minus 1, C1 minus 1, 2, and minus 1, 1, minus 2. So let's go to solution. Look at our solution for this question. Come out to say force. We know force to be what? Mass times what? Acceleration. And the force is equals to what? Kilogram. And the acceleration due to gravity is what? Meter per what? Seconds what? Squared. And from here, I can get a kilogram meter all over second what? Squared. I can have this to be what? What's the dimension of kilogram? Capital M. What's the dimension of meter? L. What's the dimension of seconds? T. And that's T squared. And this can be given as capital M, L, T minus 2. That means, that implies that what they give me, mass raised to power x, r raised to power y, and t raised to power minus z. T raised to power z is equals to m raised to r and t minus what? 2. This is the same base. You remember what the law of indices tells us. If we can make them to have the same base, this is the same base, automatically their power is equal. If we can make the two sides of the equation, of the indices equation, to have the same base, automatically their power is equal. Base M, base R, base T. Base M, base R, base T. And you remember that anything you write is raised to power 1. Just like this M9 is raised to power 1. And this L as well is raised to power 1. Therefore, I can say that X is equals to what? 1. I'm equating the power now. Then again, and my Y is equals to as well 1. And my what? Z is equals to minus what? 2. And my answer become what? 1 comma 1 and what? Minus what? 2. Can we look at the option they give us now? I look at option A, which is option A 1 and 1 2. No. Option B, I look at it as 1 1 minus 2. That's my answer. My answer is option what? B. Looking at this, you see that our answer is option B. That's the question number 7. Question number 7 says, which of the following is the dimension of pressure? Which of these following is the dimension of pressure? They look at option A, option B, option C, and option D. Then automatically what they told us here is to look for what dimension of what pressure. Before I can get the dimension of pressure, I'll first of all define pressure. I will now say that pressure is equals to what? Force over what? Area. Pressure is force over area, which means F over what? A. And the F is what? Mass times what? Acceleration over what? A. I can now have this to be what? The mass is mass, kilogram, and acceleration is what? Meter per second what? Squared. And my what? Area is meter squared. I can now move to have this to be what? Kilogram, meter, all over what? Second squared divided by what? Meter squared over 1. And this can give me as well kilogram, meter per second squared times 1 all over meter squared. And this will have this kilogram, meter all over second squared, meter cube. 1 meter destroy 1 meter here. I will have kilogram, then second squared meter will remain. And the dimension from this unit will give me capital M all over T squared and the what? L. And this can be written as ML minus 1 and T minus what? 2. And this is my what? Dimension of pressure. I look at the option and I see the option A. Option A is the correct answer here. That means my answer is option what? A. That's the answer of this question. Yeah, that's the question number 8. The question number 8 says the internationally agreed system of units, that's the XI unit, for a physical measurement are, what does it mean? Are what? Automatically they said A, option A said 1B, foot seconds, gram meter seconds, kilogram meter seconds, cm gram seconds. Man, this is a simple question. What it means, they are asking us the fundamental unit of what? Phases. Fundamental unit in phases. And we have 7 fundamental units which I mentioned earlier in our section A of this question and answer. Then we'll talk about the fundamental unit, which is the length measured in meter, and the what? Mass measured in what? Kilogram, and the what? Time measured in seconds, and the others. Looking at this now, I want to see that this is off. There's nothing like foot in the fundamental unit. There's nothing like gram in fundamental unit. There's nothing like what? Cm in fundamental unit. But we'll have kilogram, meter, seconds. That's our fundamental unit, which I circled for you the time I was dealing with them. So we now said our answer of this question is option what? C. Our answer is option what? C is the answer, because kilogram implies what? Mass, which is the basic unit. Meter implies what? Length, which is the basic unit. Seconds implies what? Time, which is the basic unit. Thank you. Yeah, question number 9. Question number 9 says, which of the following unit is equivalent to this? Which of the following unit is equivalent to this? Then we'll look at the option solution. Let's go to solution. Which of the following unit is equals to this? I have kilogram meter second minus 1. And this is something as kilogram meter divided by what? Seconds. And this is something as what? Kilogram times kilogram over 1 times meter over seconds. And this will give me kilogram. This meter over seconds is what? Velocity, which is V. And this kilogram will give me what? Mass. Mass times velocity. And mass times velocity is a what? Momentum. Mass times velocity is a momentum. And the unit of momentum is a what? Newton seconds. The unit of momentum is Newton seconds. And when we look at it, we'll see that our option here is Newton seconds, which is our answer. My answer is option what? C is my answer. There is a question number 10. Question number 10 said, which of the following consists entirely of vector quantity? Which of the following consists entirely of vector quantities? Option A said velocity, magnetic flux and the reaction. B said tension, magnetic flux and mass. C said displacement, impulse and power. D said work, pressure and the moment. Men of Galilee, look at this option solution. Looking at this option given to us, we'll look at this. Velocity is a what? A vector quantity, because the velocity is defined as what? Displacement, which is a vector quantity over time taken. Then magnetic flux is also what? Vector quantity, because it has a what? Direction and magnitude. Then the reaction is also what? A vector quantity, because action and what? Reaction has a what? Direction and what? Magnitude. Then coming to B, tension and mass are not what? They are not a vector quantity. Coming to C, displacement is a vector quantity. Impulse and power is not a vector quantity. Work done is not a vector quantity. D, pressure is not a vector quantity. Moment is not a vector quantity. So our option A, our answer become option A. Our answer is option what? A, which comprises velocity, vector quantity, magnetic flux, vector quantity, reaction, vector quantity. The answer becomes option what? A. Yeah. There is a question number 11. Question number 11 said, a lorry travels 10 kilometers northwards, 4 kilometers eastwards, 6 kilometers southwards, and 4 kilometers westwards to arrive at a point T. They now ask us, what is the total displacement? They give us option. Look at the option they give us here. Then let us look at the solution. Total displacement. Displacement is a vector quantity which has a direction and magnitude. Let us look at the statement. They said a lorry traveled 10 kilometers north. 10 kilometers north. Look at that. If I start from here to say they traveled 10 kilometers what? North. Look at 10 kilometers north. 10 kilometers north. What again? They said 4 kilometers east. Where is the east? You remember, this is my what? North, east, south, and west. You remember? So he traveled what? 4 kilometers eastward. He moved this way. 4 kilometers eastward. 4 kilometers. That's him. What again? They said again. 6 kilometers southward. What is it southward? He traveled what? 6 kilometers what? Southward. 6 kilometers southward. What again? They said 4 kilometers westward. Then he traveled 4 kilometers westward. 4 kilometers west. for westward. To arrive at a point T, what's the point? Look at the point here. Point what? T. This is a 10 kilometer. You remember? From here to here, 10 kilometers. See where it started and move, move, and move. Then what happened? Watch what happened here. If I'm taking this direction to be what? A positive direction, and I'm taking this direction to be a negative direction, I find out that this will cancel this in a what? Displacement. We say displacement is a distance move in a what? Specific direction. A distance move in a specific direction. Look at the direction. If I'm taking this direction to be positive, this particular direction will be what? Negative. It will cancel this. This one will be cancelled. Displacement of me moving to this and come back to where I started becomes 0. Then again, if I'm taking this direction to be what? Positive. I'm taking this one to be what? Negative. I will find out that this direction will cancel this direction, giving me that 6 here will be what? 0. That means what will remain here now will be what? 6 kilometers, and what remain here will be what? 4 kilometers. This 6 kilometers plus 4 kilometers giving me the distance of this, which is 10 kilometer dimension. And this 6 kilometers in positive direction, 6 kilometers in negative direction, they cancel each other. This 4 kilometers in positive direction, 4 kilometers in negative direction, they cancel each other. And what remain as my displacement is 4 kilometers, which is from here to here, which is 4 kilometers that remain. So my displacement after this movement, what will remain? Displacement is what? 4 kilometers. On what direction? What direction now is it moving? Remember that it's moving this way, right? It's moving this way, so it become what? What? 4 kilometers north. 4 kilometers what? North. It's moving towards north. You remember 10 kilometers to north. So if this is out of the game, this one is also moving to the what? North. I was saying what? 4 kilometers north. That's the answer. 4 kilometers north. I look at it. Can we see 4 kilometers north, which means option B? My answer is a what? Answer is option what? B. My answer is option what? B. 4 kilometers north. That is the question number 12. The question number 12 said the diagram below shows forces 4 Newton, 6 Newton, 10 Newton, and 8 Newton, which act at a point O in the direction indicated. The next horizontal force is dash. The next horizontal force, that was the axis, is what? A, option A is what? Option B is this, option C is this, option D is this. The next horizontal force. Then you remember that the force that is not, the real force we have, the two real force we have is a vertical force and the horizontal force. The force that acts in the horizontal is a real force, and the force that acts in the vertical is a real force. And any force that is inclined at an angle is not a real force. Any force that is inclined at an angle is not a real force. And therefore, for us to get the real force of this force that's inclined at an angle, we resolve it horizontally and vertically. I think you get what I'm talking about. That the two real force we have is a force that's acted in the horizontal. As I'm pushing a vehicle, is a real force. I'm pushing everything I'm using, all in my energy goes to pushing. Then again, if I push somebody up like this, everything I have is given to it. That's a real force. The whole force applied. But when a force is inclined at an angle, it's no more a real force. It's not the whole force that's being used to do that action. Therefore, it's not a real force. For me to get the real force of that force, I have to resolve it horizontally and what? Vertically. I will resolve horizontally and vertically. Assuming that I have this now, if I resolve this now what, like this is the vertical, we call this y, and I call this what? X. I get what I'm saying, yeah? Then I can indicate it by saying force of what? Y, that's the vertical force, and this one what? Force of what? X, meaning what? Horizontal force. And if I'm doing like that, I know that I'm looking at what? Adjacent for this man. I'm looking for what? Opposite for this man. Therefore, if I'm looking for adjacent, it will be what? Adjacent, which is force of x over hypotenuse, which is this f, is equals to what? Cos for horizontal is cos what? Theta. Then finding for x, I will have that x is equals to what? F times what? Cos what? Theta. That for that. If I'm talking about now vertical, which is what? Vertical, I will talk about opposite of this angle, opposite, which is what? Opposite is f y, opposite over hypotenuse, I will say what? Fy over hypotenuse, which is f, is equals to what? Sine theta. Opposite over hypotenuse is sine theta. And this will give me Fy is what? F times what? Sine theta. That means the component of this force horizontally is this. The component of this force horizontally is this. The same this force, the component of this force vertically is what? This. I think I made myself clear here. This particular force, its component, the real force of this force that is inclined at this angle, the real force of it in horizontal direction is this. The real force of this man in the vertical direction is this. So when I'm talking about vertical, I'm talking about the force stands for sine theta. When I'm talking about horizontal, the force stands for cos theta. Therefore, what they ask me here is a horizontal. They didn't ask me of vertical. They said resultant in horizontal. You look at this horizontal, this force is acting in this way, this force is acting this way. I think we are following. This force is acting this way, this one is acting this way. Therefore, I needed to resolve this force horizontally. I have to resolve this one horizontally. And when you resolve this force that goes this way horizontally, you know that it will move this way. When I resolve this force horizontally, it will move this way. That means this, and this will be moving this way. I think you get me right. Can we go to it now? Can we come over here? I'm resolving this force now. The force A, I said for. I will now say for 8 nothing horizontal. I will say that what? Fx is equals to what? 8 times what? Cos 60. Are you get what I'm saying now? And the cos 60 is 0.5. 8 times what? 0.5. That's cos 60. Cos 60 is 0.5, which is half. How do we get half? Oh, somebody will ask me, how did I know that cos 60 is a 0.5? Well, remember, this is what you're supposed to put in your brain anytime. You're supposed to recall it from your brain. From your brain, you get this. You know that this angle like this, I have this angle like this, and this angle here is 60, and here is what? 30, and here is root 3, and here is 2, and here is 1. Then I'm talking about what? Cos 30. Cos 30, I'm talking about what? Cos 60. Cos 60 is what? Adjacent over hypotenuse. Adjacent, which is 1. Look at the adjacent over hypotenuse will give me 1 over 2, which give me half. I get what I'm saying now. If I'm not talking about what? Sine 60, opposite over what? Hypotenuse, which will give me what? Root 3 over what? 2. Therefore, go back to what we have here. So you needed to put this in your brain all the time. From there, I bring it. That's why I bring one. I say 0.5. I said cos 60, I bring this in my brain, it's already in my brain. I know cos 60 is 1 over what? 2, which is adjacent over hypotenuse, and I have 0.5. And this will give me what? 4. That means this is 4 what? Nothing. That means 4 nothing is also acting this way for force 8. And I come for force what? For 6 nothing. I will say that for horizontal or for 6 nothing will be equal to what? 6 times what? The same thing, cos what? 60. Cos 60 will give me what? 6 times what? 0.15. 0.5 will give me what? 3 nothing. 0.5 times 6 will give me what? 3 nothing. That means half of what? 6 will give me 3 nothing. And that will still act in this way. So how many force is acting in this way now? The forces acting in this way is 3 nothing, 4 nothing, and what? 10 nothing. And the force acting against them. Look at this one, acting against them is what? 4 nothing. Remember, this first line I resolved horizontal is acting this way. This one I resolved it horizontal is acting this way. So how many force acting this way? Just like 3 people pushing a vehicle this way and 1 person pushing the vehicle from the back, from the front back to them. I will have total resultant force R. Resultant force, I represent it with R, is equals to the force acting this way will be what? 10 nothing, which is already this one, plus what? 3 nothing, which is this one, plus what? 4 nothing, which is what? This one. This is the no force that is acting this way, minus the one opposing them. Look at the one opposing them. 4 nothing. 4 nothing is what? Opposing them. I will now have that the resultant force, this plus this plus this will give me 17 nothing. 17 nothing minus what? 4 nothing. And I will have my R to be what? 17 minus this will give me 13 nothing. Therefore, my resultant force is a what? 13 nothing. My answer is what? 13 what? Nothing. And I go to option to see where I will see them. And I see that option D is 13 nothing. I will say that my answer is option what? D. My answer is the what? Option D. My answer is the what? Option D. Yeah, there is a question number 13. Question number 13 says 2 forces of magnitudes 7 nothing and 3 nothing act at right angles to each other. The angle theta between the resultant and the 7 nothing force is given by what they asked me here. The angle theta between the resultant and the 7 nothing force is given by. They give us option. Let us go to solution. Let us go to solution without delay. Let us go to solution. I have what they said is 2 what? Force, which is the force. And that force, I call this one F. I call it what? 7 nothing. And the second force is what? 3 nothing. Look at the second force, which is what? 3 nothing. Then my resultant force move from this point. That's my resultant force. And that's my resultant force. I call it R. And this R, I have this to be what? Angle between the resultant force and this 7 nothing. I call the angle theta. That is the angle between the resultant force and the what? 7 nothing. I call it angle theta. Then now, you remember, looking at this thing I draw now, that this implies the same thing as drawing this way. Are you following? These things now is these things like this. If I have this a line, you know that this line, this is the angle, and this line as well. I have this. Are you get what I'm saying? And this is the word theta, and this man is 7 nothing. And this man is also 3 nothing, and this man is 3 nothing, and this man is 7 nothing, and this is our resultant. And that thing I draw there can be drawn this way by saying that my word, this become my word 3 nothing, and this become my 7 nothing, and this become my 3 nothing, and this become my 7 nothing, and this become my resultant force. Are you get what I'm saying? Yeah? And this become the angle I'm talking about, theta, and this is my word R. Look at it. See what I did? I just turned this like this, like this. Keep out. Look at it. I carry it like this, or I carry this one like this, turn it like this. Are you get what I'm saying? Yeah? And this is 90, and this is 90, and also this is 90. Are you following? Then now, I cannot say that angle. What they asked me is what? The angle between the resultant force and the what? This force is what's given by that. And so the angle is given as what? Opposite of the angle over the adjacent of the angle. Opposite of the angle. Opposite of the angle over the adjacent. Where the angle is sitting is the adjacent. And the line that closes it is what? Opposite. Opposite over adjacent will give me what? Tan. Opposite over adjacent will give me tan. That means 3 all over what? 7 is equals to what? Tan what? Theta. You get what I'm saying now? Opposite over adjacent will give me what? Tan theta. Therefore, my answer is what? Tan theta. Tan theta is equals to what? 3 over what? 7. And I go to option they gave me there. I see, looking at the option, look at it, I see that tan theta equals to 3 over 7 is the answer. That means my answer is option what? C. That's option C is the answer of the question. And that's the angle between the what? The resultant and the what? 7 nothing. Thank you. There is question number 14. Question number 14 says 2 forces whose resultant is 100 Newton are at right angles to each other. If one of them makes an angle of 30 degrees with the resultant, make an angle of 30 degrees with the resultant, determine its magnitude. We should determine its what? Magnitude. Magnitude of the one that makes an angle 30 with the what? The resultant. We go to solution. This is our solution. This option given to us. If I take the forces to be this and this is the two force. If I'm taking it to be this and this is the resultant, this is the resultant forces, I call it R, and it's 100 Newton. That's what they say. Resultant force 100 Newton. If I call this force of this one to be Fx, which is horizontal force, and I call this one what? Fy, which is what? Vertical force. And I'm taking this man to be the one that makes an angle 30 degrees with this. If you also take for this man, it will still get the same answer what I get. You will still get the same what? Answer of what we are going to get here. If you take it to be this man to be angle 30, it will still get the same answer. And look at the what? Resultant force. Looking at it now, I want to get it. They said that I should get that force that I made the resultant force with this man. I cannot say here that this man, which is the one that makes it 30 degrees with the resultant force, is what? Adjacent over hypotenuse. Adjacent where the angle is sitting on is what? Adjacent. The line where the angle is sitting on, look at the line the angle is sitting on is adjacent over the hypotenuse, which is the cap. This one is opposite. This one, adjacent over hypotenuse, is what? Cos. I can now say this man adjacent over hypotenuse, which is 100 Newton, is equals to cos 30. That's what I mean. And I mean that what? Fx is equals to what? 100 times what? Cos 30. Can you come up here? You come up here, let me finish it here. I can now say that what? Fx is equals to what? 100 times what? Cos 30. You remember? Then now, what's the cos 30? And I will recall my diagram for cos 30. I can now say, look at this. From my brain, I bring out my diagram from my brain. You remember this diagram, which will say that here is 60 degrees, and here is what? 30 degrees, and here is root 3, and here is 2, and here is 1. I'm talking about cos now. Cos become adjacent. Are you going to say that? Adjacent over hypotenuse. Are you going to say that? This is where the angle 30 is sitting on. It's sitting on this line. This man become adjacent over hypotenuse. That means that cos 30 is equals to what? Root 3 over 2. Are you get what I'm saying now? That means that cos 30 adjacent over hypotenuse becomes root 3 over 2. I cannot say that fx in my brain become 100 times what? Root 3 over what? 2. Remember this all the time. Put it in your brain. Make it constant in your brain. And this will be equals to 100 times root what? 3 divided by 2. And 2 divided this will give me 50. I have 50 root what? 3. And that's my what? Answer. 50 root 3 is my answer. I will now go to option to look for that. I look for option A, is not that. Look option B, is not that. Option C is not that. I look at option D, and that's the correct answer. And that is what? 50 root 3 nothing. And my answer is what? Option what? D. That's our answer here. Yeah, that's the question number 15. Question number 15 says, a man walks 1 kilometer due east and then 1 kilometer due north. His displacement is, look at the option, his displacement is what? This. We'll look at the solution. Look at the solution first without wasting time. They say a man walks 1 kilometer due east and later walk what? Then 1 kilometer due what? North. Look at it. He moved this man like this. He moved like this. Do what? East. Look at east. Then now from there he move again. Do what? North. And this is 90. Are you get what I'm saying now? And this is what become the direction of resultant force. Look at resultant what? Force. And this is R. And this 1 kilometer due east, 1 kilometer due what? North. That's what the man did. Then now what they asked us, they said the displacement. And I started by saying, number one, let us see the distance. We say distance is covered, distance is covered. Distance covered by the man is equals to what? 1 kilometer plus 1 kilometer, and that gives me 2 kilometers is the distance he covered. Then now let's look at what displacement. We'll now say that displacement, number two, displacement is a vector quantity, which is what? The R resultant. Displacement is what? R squared is equals to Pythagorean theorem. This man become 1 squared and plus what? 1 squared. That's the Pythagorean theory. Or I just put hypotenuse squared is equals to adjacent plus what? And the opposite. And this will give me R squared is equals to what? 1 squared is 1 plus what? 1 again. And I will have that what? R is equals to square root of what? 2. And that's my R resultant what? Force. The resultant what? Force, which we call displacement, is what? Root 2 kilometer. That's what it is. Then what's the direction? You remember that the direction of resultant force is the angle he made with the horizontal. The direction of resultant force, note it now, the direction of resultant force is always the angle he made with the horizontal. And what's the angle he made with the horizontal? Look at the theta. And for me to look for it, I know that what? Opposite of adjacent is tan, right? And that tan will give me what? That's the tan opposite over adjacent. Tan theta is equals to 1 over what? 1. That means tan theta is equals to what? 1. And what's the angle? I can now say that theta is equals to tan inverse of what? 1. And where will I get it? Because I don't use calculator in writing JAMB. I don't use calculator. I now go back to remember my what? My diagram, which is always in my brain. That my diagram is always in my brain. I look at it like this, and this is what? 90, and this is 1, this is 1, this is root 2, and this is giving me 45, and this is giving me 45. I can now say the what? Opposite over adjacent, which is what? Tan 45 will give me 1 over 1. That is opposite over adjacent will give me tan 45. That means that tan 45 is equals to what? 1. And it means that what? 1 tan 45 is equals to 1. Tan theta equals to 1, meaning that theta now here is 45. And that means that what? Theta is equals to what? 45 degree. I take it up. Tan 45 is equals to 1. Tan theta is equals to 1, meaning that theta is what? 45, which gives me what? 1. And I've seen the angle, which is the resultant made with the horizontal. I cannot say that my answer, my resultant force is what? Root 2 kilogram. That's the resultant force. Which direction? Is moving from what? This angle, this way, right? And remember that this man moved this way. He moved from here to this, and he moved from here to this. And my resultant moved to this to cancel the effect. This man moved this way to this, and this to this. My resultant force moved this way to what? Cancel the effect. Meaning that my resultant force is moving from what? The south. Is moving from north to what? Is moving from what? North to what? East. Look at it. Moving from what? North to east. North to east. I will not say is what? North to what? East of 45 degree. That's to what? East. Moving from what? 45 degree. From what? North to what? East. Look at north to what? East. That means that's my what? Answer. And I go to option here. I look at this one. It's not the option. I look at this one. This one is correct option. That's my answer. My answer is what? Option what? B is my answer. And that's